Phew! My name is Michael Rosario, and we are going to learn how to code in R. So I'm just going to open my R Studio and get ready for today's lesson. So previously we learned about the for loop, and we did some really simple batch automation using the for loop. And so once you get your data files into R, once you get those CSV files into R, one of the first things that I like doing is to visualize those data and to plot it. And so in this lesson, we're going to be talking about the scatter plot. Sorry. And so I just want to say that there are a bunch of great plotting tutorials. They're online, so you could just go to Google and type in like R and plot, because that's a function we're going to be using today. But what I want to focus on today is a trick that I've learned over time on how to get, the right scaling into these scatter plots. But first, let's do some simple scatter plots just so that we're all on the same page. And so for today, I'm going to be using these CSV files, data1 and data2, which we've used in the past. And it's basically what we've seen before. It's time, distance, and force data. But what I want to see in this case is I want to see what force looks like over time. So the y-axis is going to be force, and the x-axis is going to be time. And I want to compare the data in these two different CSV files. So I'm just going to do some setup, and hopefully this is second nature to you by now. And if not, please go back to the other tutorials. But I'm going to set my working directory to source in today's lesson where I have my CSV files. And I'm just going to check to see what's in here by listing the files. And you can see there data1 and data2.csv. Alright, so I'm going to work in the script now. And I'm just going to call it data1. As my temporary variable, and we're going to read CSV data1.csv, and that's all good. And we're going to do the same thing with data2, read CSV data2.csv. And for a scatter plot, all you really need is a x equals and a y equals. And what do we say? We said that our x was our first column, so I'll just work with data1 for now, and we're going to put in our first column, so that's why we have the comma 1. We want all the rows in the first column. And for y, we also want data1, but in this case we want the third column. So that should be all we need to create our first scatter plot. So I'm just going to hit Control-Shift-S to run this entire script, and kaboom! There is our scatter plot. And these labels kind of bug me because, who really knows what data1 column 3 is? So I'm going to show you guys some arguments in the plot function. One of them is xlab for xlabel. And what do we say? This will be time in seconds. And make sure this is in quotation marks. That's really key here. And then we're going to put in a comma and another. Sorry, I forgot my parentheses there. We're going to put in ylab for ylabel. And this will be force measured in newtons. And one more. Another cool argument is main. And this will be the main title. So I'm just going to say scatter plot. Right, so let's run the entire script again. Control-Shift-S. And we can see now we have some nice looking labels here on the x and y axes. And scatter plot. And I want to do one more thing. Is I want to change the color of these plotting points. Since we're going to be plotting two data sets over this graph, it would be nice to know how to change the color of the points. And that's simple. That's comma. And the argument is col for color. And then in parentheses, you can just say red. So we're going to do Control-Shift-S. And there you go. Red and data points. Beautiful. Alright. So that is how you do a scatter plot for one set. But the problem is we can't use the plot function again, because every time you run the plot function, it erases everything that you've done previously. And what we really want to do is add to our current scatter plot, right? So right now, this is only represented, the scatter plot is only representative of data 01, but we want data 02 on there. So the way that we can do that is instead of using the plot function, there's another function, I believe it's called points. And it's the same, it just takes in the x equals and it takes in the y equals. And here we can say data 02, column 1, right? The first column is the x-axis, and data 02, comma 3. And I'm just going to put a color, col equals, and let's make this blue. So I'm going to run the entire script again, and we should see blue points. Great. And if you have data 3, data 4, however many CSV files you want to add onto this plot, you just do the same thing. You could run the points function again and again and again. And that's basically how you add points to a currently existing plot. Now the problem is you can't see all of the blue points. They sort of go off the axes, and that's because when you run the plot function, it sort of optimizes and guesses the best set of the region for the x-axis and the region for the y-axis. And that's a little problematic, just because there, we don't really see what's going on over here in data 2 in these blue points. So I'm going to show you a trick that involves the function C, which stands for combine or concatenation. That's, everyone, we should say that. Concatenation? Concatenate. Okay. And what is a concatenation? It basically takes something and adds it to the end of something to create a vector. So here I'm writing C 1, 3, and I'll just put like a 9. Oh, that was an 8, but that's a 9. And when we hit enter, it basically takes whatever we put in there and creates it into one vector. So one use of this is we could take all the y points for data 1 and all the y points from data 2, from data 1 and from data 2, and we could combine them or concatenate them together to get one vector. So let me show you what that looks like, and then I'll explain to you why it's important. But it's really simple. So we put in the C, and then we say data 1, third column, right? And then we do data 2, third column. And when we hit enter, that's it. That's our one long vector with the third column from data 1 and data 2 all together in one thing. Now, the reason why we want to do this is so that we can plot this vector, which is the combination of our two data sets, in one go. That way R automatically will set up its axes so that it can see all of these points. If that didn't make any sense, maybe it'll make more sense if I actually type it. So I'm going to do that. I'm going to make a new plot down here. And again, we're going to have an x equals and a y equals. This is how I always start my plots. It's a lot easier this way. So in here we had data 01 first column or whatever. But what we want is the concatenation of the first and second data file. So we're going to put a C. It's a function, so we put the parentheses. And we say data 1 first column. And then we put a comma. And then we want the other data file, data 2, also the first column. And we want to do the same thing for y, but now we want to do it with the third column. So let's see, concatenate data 01 third column, comma, data 01 third column. Sorry, this should be data 2. 02. Right, so let's run this and see what happens. Alright, so now we can see all of the points, but the problem here is that they all look the same. But what's important is that the axes are set up correctly. So what if we could plot this with these axes but no points? And the way to do that is you add the argument type is equal to n in the quotation marks, which stands for none. So when I run this, I get a blank slate, but with the correct axes. And now what I can do is this points command that we used previously to add points to our current plot. We can do that again. So I'm just going to copy and paste it. And here I'm going to change this to data 1 and change this to data 1 and make this color red. And now when I run the entire script, it'll plot a blank slate with the correct axes. It'll put points from data 1 on top in red, and then it'll put points from data 2 on top in blue. So Control Shift S, and that's what we have. And so that's all that I really have for this lesson, and that might have been a little rushed, but this is something that we've found to be really helpful. Just because you could go in there and change all the parameters yourself and like make custom, set the x-axis to this and this, and the y-axis to this and this. But this is automated, and I like having R do stuff for me, as should you. But yep, that's all I have. And as always, keep R'ing and keep sourcing.